This is actually pre-calculus, even though it says Algebra 2 here. This is pre-calculus lesson 9-1, a review of Algebra 2. Today we're talking about radians, degrees, and trig functions. I kind of glossed over what radians are. I want to do a more in-depth lesson on what radians are. So, if you have a circle with a radius of something, it is called a unit circle. A unit square, by the way, is a 1 by 1 square. It is a unit because the area of that square is 1. The sides are 1. It's a unit square. A unit is just 1, right? So a circle with a radius of what is a unit circle?
Pi?
Unit circle.
Oh.
Unit circle.
1?
1, yes. So it's a circle with a radius of 1.
Oh, God.
Cool. So that is a unit circle. I'm going to be talking about the unit circle a lot in the next 2 weeks, so know that whenever I say unit circle, I'm really just talking about a generalized circle that has a radius of 1. So far, so good? All right. Review. Circumference. How do I find circumference? What's the formula for circumference? Uh-oh. Has it been that long from geometry?
Yeah.
It's 2 pi r.
Oh.
Some people also write this, and I'm going to write this in green because you don't need to write this. Some people also write this as pi times diameter because diameter is 2 times the radius. But this is the one I normally go to all the time, 2 pi r. And I know what r is now. On the unit circle, r is 1, so the circumference is how big? How long is the circumference?
It's 2 pi?
Yeah, it's just 2 pi. What that means is, and by the way, circumference, if I cut open this line and I stretch it out into one solid line and I measured how long that was, if I measured how long that would, it would be 2 pi. And another way of thinking about it, if I'm a tiny little ant and I walk all the way around the circle, the distance that I walk as the ant is 2 pi. Circumference is just the distance on the outside of the circle. So far, so good? All right, so the unit circle, you just need to know this in the back of your head. Unit circle, when I go all the way around it, I go 2 pi. I walk 2 pi distance. So I need to talk now about radians. Degrees, if I think of degrees as like a snowboarder, if I do a full revolution, I've gone how many degrees? So this is me here as a snowboarder. I'm riding down the hill, and then all of a sudden I go.
360.
What? Yeah, I just did a 360.
Oh.
So if I go all the way around the circle, I go 360 degrees. Write this down in your notes. 360, and then the little circle at the top right is called the degrees. So 360 degrees. Here's the problem with degrees. We mathematicians love pure numbers. We don't like these pesky units. Those are for physicists and less pure applications of mathematics. We like pure numbers. Degrees are not pure numbers. The unit there is degrees. So how do we convert this into a pure numbers? Radians. Radians are this pure number, this unitless number. Okay, so radians is how far I went on the unit circle. I went 2 pi. So there is my ratio. Degrees over radians, the same thing as 360 degrees over 2 pi. You now have a formula to convert between radians and degrees. If I've gone 360 degrees, I've gone 2 pi radians. If I've gone half of that, 180 degrees, how many radians have I gone? Okay, so the question again, if I have gone 360 degrees, that means I've gone 2 pi radians. What if I did half of that? If I went 180 degrees, how many radians would I have gone? Pi. Does that make sense, Daisy?
Yeah.
Yeah? Okay. So I want you to visualize also what a radian looks like. A lot of people don't know how big a radian is. Let's go ahead and do that. Do you have your calculators on you real quick? Phones or laptops? Go ahead and type in 360 divided by 2 times pi.
Wait.
Type this fraction in. What does a radian actually look like?
So 360.
How many degrees is a radian? 360 divided by 2, then divide by pi, and you get?
Divided by pi.
Yeah, 360 divided by 2 pi. If you do it in parentheses, then you can enter it all at once. Otherwise, you can do 360 divided by 2, and then after that, divide by pi. Either way works. And you get?
How many decimals?
2.
57.30.
0.30. Okay. Look over here on the right-hand side of your own notes. I have given you 57.3 degrees. That right here is 1 radian. Label it. 1 radian.
What?
That's what a radian looks like. It is that slice of pi of the
That's
unit
so
circle.
cool.
That's what a radian looks like. Notice, this is kind of cool. Notice that there isn't a whole number. There isn't an integer number of radians that fit into a circle. I have a radian here, 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 here. I have 1, 2, 3, 4, 5, 6 of them. And then this leftover piece, 16.23. Any reason why we'd have a leftover piece? Any ideas? The reason is because I have to have pi in there.
Oh.
So this is, if I went pi, I would have gotten to right here, and then this extra piece is twice this amount of pieces, so that's why I didn't come in. This whole distance is 2 pi, but if I just have something without pi, I'm not going to have an even number going around. So you know what a radian looks like. How do you convert degrees to radians? So say you had degrees here. This box here represents degrees. What am I going to multiply to get to radians? And you're going to use this fraction up here. In order to get to radians, I'm going to take the reciprocal of this.
Oh, I love that word.
I'm going to take the reciprocal of this because I want radians on the top. I want radians. So radians needs to be on the top. When I take the reciprocal of this fraction, I get what fraction? Just shout it out.
2 pi over 360.
Exactly. Now reduce that fraction.
Huh? It'd be pi over 180.
There it is. Pi over 180 degrees. Write this down in your notes. This is the way to convert any degree that you have. If I give you 225 degrees, you plug this in, you do 225 times pi divided by 180, simplify that fraction, and you get how many radians.
What is the box for?
The box represents any degrees. I could have said x here. I could have said 220 degrees. It represents degrees. So anytime I'm given degrees for the input for the box, multiply by this thing, and I will convert to radians. Now let's do the reverse of that. What if I have radians? This box now represents radians. I want to convert to degrees. What do I multiply by?
You would multiply by 180 over pi.
180 degrees over pi, yeah. Write that down in your notes. That's all you need for half of the homework. Half of the homework, by the way, tonight is on Khan Academy. The second half of the homework, which refers to the backside of the notes, is on paper. Yes.
Ew.
That piece of paper in front of you. Perfect. So we have 2 examples, and then we get into some trig functions. Actually, I guess it's not technically in the back. Right here is where we start our next part of the lesson. So example 1, convert 135 degrees to radians. So what am I going to do to this 135 degrees? I'm going to multiply by one of these 2. Which one is it?
Pi over 180.
Pi over 180. Why is it pi over 180, Daisy?
Let me switch them.
Daisy, Daisy, Daisy.
Do that. Because you're converting it into radians.
And that's the formula I gave, right?
Yeah.
Here's another reason. Are you ready for this, Daisy? Units will cancel out. Look at this. I
What?
have degrees on the top, blah, degrees on the bottom. Blah. They cancel out. You're just left with pure, mathematically unitless radians.
Conversion.
Oh.
All right, so when I do that, I get 135 pi over 180. I need to simplify this fraction. How do I do that? What can I divide the top and bottom by? Anything at all.
Let's go by 5.
Yeah, let's divide the top and bottom by 5. The numerator and denominator by 5. 135 divided by 5 is
23.
close, 27.
Go for it.
I'm just kidding.
You know,
I'm joking.
The reason, okay, you guys know the trick for dividing by 5?
Huh?
You know the trick for dividing by 5?
What is it?
You multiply by 2 and then move the decimal place. So, for example, 135 times 2 is, well, this would be 26, carry the 5, it would be, maybe that's not a shortcut. It is for me. 135 times 2 is 270, move the decimal place, 27. Let's try it down here. 180, double that.
That's 360.
Move the decimal place,
36.
there it is.
I just go through my head and be like, what's this 5 times 1 equals 18? And use a leftover.
That also works. So 180 divided by 5 is 36. Can we simplify this anymore?
Yes.
Yes?
3.
Yeah, 3. How did you know that the top and bottom were divisible by 3?
Because,
You just knew them.
yeah.
Okay, that works. Another way, if you don't know, is you add the numbers So 2 plus 7 is...
Oh, nice.
Sorry, I didn't mean to laugh, but 2 plus 7 is not 10. It's just funny because we're in pre-calculus and we can't add 2 plus 7. So 2 plus 7 is 9, yes. 9 is divisible by 3. 3 plus 6 is also 9. 9 is divisible by 3. If you add all the digits, that should also be divisible by 3.
Then also you would be
Yeah.
able no.
Don't hit.
You can divide 9 then.
Yes.
Shut up.
Wait, no, that makes up. I thought it was 10 because I was thinking of 3, okay?
Okay. So if I divide the top and bottom, the numerator and denominator by 3, thank you for bringing back those calculators. Did you count them up to make sure it's 22?
Yeah.
All right. Thank you.
You were like,
All right. 27 divided by 3 is...
9.
36 divided by 3 is...
12.
Top and bottom divided by 3 is...
How much are there?
22?
3 and 4.
I will look for that.
All right, thanks. 3 and 4. And don't forget that throughout all of this, I've been forgetting to write my pi. Pi didn't go away. That could have been a teacher error. I should have let you find it. But there's my answer. It's 3 pi over 4. Final answer, box it, 3 pi over 4. We know how to reduce fractions. We know how to convert to radians. We're good with example 1. And...
Dad.
Let's go to example 2. Okay, now we have this fraction with pi in it, this radians. We're going to convert this radian measurement into degrees. So how am I going to do that? 5 pi over 3, what am I going to multiply by?
Multiply by 185.
And Daisy, why do I do that?
Wait, I'm sorry. I have no idea what you're saying.
I'm going to multiply this 5 pi over 3 radians by 180 degrees over pi.
Converting into degrees and you
What will cancel out?
What?
What will cancel out? How do you know this is the right one?
The pi, I mean.
Yeah, the pi canceled out this time. Pi and pi. That something will always cancel out if you're doing it correctly. So make sure that you see something cancel out. If you accidentally multiply this one by pi over 180, you're like, I'm getting pi squared. It's because you need to take the reciprocal of that fraction. You need to flip that fraction. All right. So when we do that, you could do this on your calculator and cheat, but we're going to do this in our head and not cheat. So the way that I do that is I do 180 divided by 3 first. 180 divided by 3 is the same thing as 18 divided by 3, adding on the 0 after you do that. What's 18 divided by 3? 6. So this now turns into, do a little arrow here. There's the original 5. I didn't touch that. 18 divided by 3 is 6. So I 6, 0, 60. 5 times 6 is...
300
You got the full number, 300. And don't forget our units.
degrees.
Degrees. 300 degrees. Easy peasy, lemon squeezy. Questions about example 1 or 2? All right. So that's half the homework. That's on Khan Academy. That needs to be assigned. I haven't done that yet. Let's talk about some trig functions.
No.
All right. Give me a thumbs up, thumbs down. Have we heard of Miss Sohcahtoa? Oh, you have learned about it. Okay. This is going to be easy.
It's kind of funny. Like Sohcahtoa.
Yes. Don't suck the toe.
Ew.
All right. Therefore, if you know Sohcahtoa, let's go ahead and write it over here on the left-hand side. This is how you write it, by the way. Sohcahtoa. Suck a toe. So, when we suck their toe,
Ew.
when we talk about this maybe slightly Native American sounding name, sine is equal to something over something. What does O and H stand for?
Oh, opposite
Opposite
side.
over
Hypotenuse.
hypotenuse. You already know that. But what does opposite mean if this is my triangle? So this little theta, that's what that symbol is. If you didn't know that, you can write this off on the side. I'm going to do this in green. This is optional to write. This symbol right here is called theta with a TH, not a PH. I swear, Sophia mispronounces everything. If you're watching, Sophia, I'm sorry, but you mispronounce everything. It's not theta, it's theta. It's not asymptote or whatever you pronounce it. It's asymptote. Anyway. Yeah. So pronounce this as theta. So this is my angle of reference. You do need to put this in your notes. This is your angle of fortune. Angle of reference. Sorry. Reference.
Why are you calling it angle O? You're calling that one.
Angle of reference is this guy right here. My angle of reference is down there in the bottom right. Your angle of reference might change on you. In the homework, I just kind of mix it up and I put your angle of reference on the top, on the bottom, stuff like that. Okay, so if that is my angle of reference, then this is super important. I'm going to write this in red. This side right here must be the
Okay.
Opposite.
opposite. So write opposite over here. I believe in Spanish it's el opuesto. See?
What?
Opuesto. Isn't that how you say opposite? No? Anyway, let's go ahead and talk about this diagonal line, the longest line. That's called the,
Hypotenuse.
yeah, there it is, hypotenuse.
Yeah.
And the one that we haven't gotten to, this one on the bottom, therefore must be what? Just with an A, because I have an A here.
Adjacent.
It is adjacent. See, I love review because we go through this nice and fast and we already know what we're doing most of the time. Some of this we don't know, and that's why we're reviewing.
Wow.
So if those are our three different measurements, what is cosine then? Cosine is A over H, therefore it's what, Daisy?
It is adjacent over hypotenuse.
Over hypotenuse. And Rochelle will give tangent to you.
You. Opposite over adjacent. You know, this was like the most easiest thing in my math class last year, but everyone failed.
That's awesome that you're so good at it. Hopefully everyone else in your math class currently doesn't fail at it. I don't think you will, because
I'm gonna
you
go
have a
for
pretty
that.
good knowledge of this, Daisy. I know. I mess with this a lot. All right, so the fancy thing here is trig functions. The unfancy thing is it's just a ratio. It's just a fraction. It's a fraction of these lengths. Pretty straightforward. We'll get a little bit more advanced when we hit our lesson notes tomorrow, and we're actually going to be calculating these things. But for now, we're just calculating what those lengths are. So, backside. I should hear papers flipping. Backside. Backside of the notes. Backside of the notes. You're flipping the paper nice and slow, Daisy. Backside of the notes. You're flipping your paper. Go, 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 go. And we're on the back. Okay, example 3. Find the following values.
Oh!
So, sine of theta. There's theta. It's the same place as I did in the notes because I want to make sure that this one is easy and you can get it. Sine of theta is what over what?
Opposite over adjacent.
Opposite over adjacent.
Hypotenuse.
Hypotenuse.
Opposite over hypotenuse. There it is. So 4 over this thing. 4 over, what is it?
Don't tell me. Wait.
It was from the warm-up. That's why I had it in the warm-up.
4 over what? Oh, wait.
Yeah, it's 4 over that hypotenuse, but we don't know what the hypotenuse is. But we do. It's a right triangle. This is 3, 4,
5.
5. Yeah, there it is.
Wait. But
Just
when
kidding.
you the one example you showed us was 6A and
6, 8, 10.
But yeah, that's why we get it's like 2.
If you multiply by 2, you get those.
Yeah.
Yep. All right, so you know this Pythagorean triple, easy peasy. So this is now going to be 4 over 5. Yeah, there it is. All right, we'll give this one to Rochelle, this one to Daisy. So Rochelle, you're doing cosine. Cosine is what? What fraction?
It would be 3 over 5.
3 over 5. There it is. It's adjacent over the hypotenuse. And therefore, Daisy, the tangent is what fraction? What ratio?
Oh, 3? No, 4. Yeah, wait.
I don't know. I'm just writing what you say.
Hold on. I am thinking. Wait, yes, sorry.
You got a 50-50 chance.
It's 4 over 3.
It is 4 over 3.
Ah,
Easy. Okay, so those are good. So far, so good. If you could not figure out what this is, and on Khan Academy, if I could put this on Khan Academy, which it's not on, I would totally make it so that some of these would be square roots.
That's dumb.
And how would I find those? If I had like 2 and 4 here, how would I find this? The same formula that we did for the warm-up called Pythag. Yeah, you'd use Pythagorean Theorem, a squared plus b squared equals c squared, to find that missing length. But luckily for you, I will always make sure you have special right triangles. Here's a Pythagorean triple that you don't know. Something 17. So I'm going to make sure you know how to use Pythagorean Theorem so that this comes out nice. I will, for the sake of all of our assignments, make sure all these come out to integers, to whole numbers that is. But they might not when you're in the actual math community. So let's go ahead and set up Pythagorean Theorem. A squared plus b squared equals c squared. A squared plus b squared equals c squared. What goes in for ABC?
We can put an 8 for A
Okay, so I have 8 squared
plus B squared.
plus b squared equals
17 squared.
17 squared. All right, I have my square list up here. 17 squared is... Thank you. 17 squared is...
Wait. Oh, it's 289.
Yeah, so now I have 64 plus b squared equals 289. I'm going to subtract 64 from both sides. B squared is therefore going to equal 200 and what?
225.
Therefore, b is equal to what, Daisy?
225.
If I square root 225?
Oh! What are you doing?
It's right there. It's up on the wall. Colorful thing, squares.
Oh!
225 square root is?
I can't even see.
Hey.
Oh, it's 15.
Yeah, 15. Nice. So this length over here must therefore be 15. Those are yours. Yep.
Thanks.
Yep. Video's not online yet because I had some trouble. But it'll be online soon, by the end of the day.
Good luck, Ben.
Thanks.
All right. Now we have all 3 of these labeled. We have opposite, adjacent, and hypotenuse. Notice that the angle of reference is different, and sine of theta is anyone. Anyone.
Oh, that'd be 8/17.
Oh man, she got it. Knew that the angle of reference changed 8/17. Make sure, Daisy, that you see that too. 8/17.
Wait.
I'm gonna pause here until you get it.
8/17, what do you mean? What are you talking about?
How'd she get sine of theta is equal to 8/17?
What is it? It's on the top.
Where's opposite?
Okay, yeah, I understand that.
Got it? All right.
Yeah.
Then Daisy, you're in charge of cosine.
Cosine? What is it again? Cosine is adjacent over hypotenuse. So, is it 15? Wait, hypotenuse is 17.
Yeah?
Right?
I don't know. What do you think, Rochelle?
I don't know.
Yeah.
Yeah, you got it. Daisy, you want to try another one? Because I think Rochelle can do this one already. I want to give it to you, Daisy. Tangent.
Why?
Because you will benefit from practicing.
Okay, fine. And then the last one is like adjacent. Oh wait, no, opposite.
Toa, so opposite, yeah.
So that would be 8/15.
Done. We're done. Those are the notes. So the back half and that first little part of trig functions, that is all on paper. That's called the Sohcahtoa worksheet. The angle of reference changes on that one, so be careful. And the front half, converting from radians and degrees, that will be on Khan Academy. Any questions before we end the video? And we're done.